Our lesson today will be on multiplying and dividing integers. You're going to realize that the topic, we're technically doing two lessons today. We're going to do multiplying and dividing integers, and you're also going to learn later on in this video how to turn fractions to decimals and decimals back to fractions. So when you're multiplying and dividing integers, you're literally multiplying like you regularly do. The only thing you need to remember is if you have two negative numbers, your answer is going to become a positive. Remember, two negatives make a positive. You can't have two negatives together. And also, if you have a negative and a positive, that's going to equal a negative. That's very similar to what we've been doing with addition and subtraction. So we're going to fill in this chart, but before we do, I want you to read the steps. Multiplying, dividing integers, step 1, you're going to ignore the signs. Just multiply and divide like you typically do. Step 2, determine whether your answer is negative or positive. That's all you have to do. We'll be filling out the chart on the next slide. So in your modules, I want you guys to omit this because we're not going to do the game. However, we're just going to fill in the different quadrants. So if you look at this box right here, and we'll do it box by box, eventually you'll be able to do it on your own. You'll notice if you look to your left, you'll see 1, and if you look down, you'll see 1. So you're multiplying positive 1 by positive 1. This quadrant number 1, should actually be the easiest for you to fill out. So I know 1 times 1, remember you're going to go through your steps. First of all, is your answer going to be positive or negative? I know my answer is going to be positive because I'm multiplying two positives. Now I just multiply like regular. What's 1 times 1? 1. Sorry if my numbers are a little squiggly. All right, now look right next to 1. It says 2 times 1. You know if you look in this box, you know your answer is going to be 2. Positive 2. Now, if you look in the next box, it says 3 times 1. So you know your answer is going to be positive 3. 4 times 1, positive 4. 5. Go ahead and do the next one. I'm going to move up to 2. 2 times 1. What do you think it is? 2. Now we're going to fill in the rest of this box quickly. I only do probably like 2 more. All right, so you get the gist. Now I'm going to go over here and look at quadrant 2. All right, first of all, I want you to fill in the numbers that should be down here. I know it should be -1, -2, -3, and so on. And then, you know, if you're multiplying a negative times a positive, it'll equal a what? Negative. Good. So you know this will be -1. In this box right here, you'll fill in -1 times 1, which gives you what? Good. -1. What about here? -2 times 1. -2. If you fill in that box, -3 times 1. -3. And then if you look at this box over here, you should notice that you're multiplying a negative times a negative. So you know that's going to give you a what? A positive. You know in this box, you'll be multiplying negative times a positive. So you know your answer is going to be, if you ever have a negative times a positive, you know all your answers are going to be negative. So now we're going to solve a few problems. However, we're not going to use the quadrants. We're just going to solve it without. So if I look at the exercise, it says multiplication of integers in the real world. Generate real world solutions that can be modeled by each of the following multiplication problems. Use the integer game as a resource. So I want you to think of a game or any real world scenario that will match with each of these problems. Then I want you to solve. So if I look at this, I look at step 1. Step 1 tells me to ignore the signs. Ignore the signs and just multiply and divide like you typically do. So if I look at A, I see, if I ignore the signs, I see 3 times 5. What is 3 times 5? I know 3 times 5 gives me 15. Now, step 2, determine whether the answer is negative or positive. Do I have two negatives or a negative and a positive? If I look, I have a negative and a positive. I have -3, +5. So I know my answer is going to be negative. So again, you just said 3 times 5 gives you 15, and you look and you're like, oh, okay, it's going to be -15. If you ever see, look at B. If you ever see parentheses like that, go ahead and rewrite the problem. So if I rewrite that, that'll look like this. -6 times -3. All right. I always think the parentheses make problems look harder than they really are. So what do you notice? Do you think your answers could be positive or negative? Look at both of the factors. You know, one factor is -6, the other factor is -3. So if I look over here, I know obviously my answer is going to be positive. I'm multiplying two negative numbers. So what is 6 times 3? 6 times 3 equals 18, and I know my answer is going to be positive 18. Now, I would rewrite this one because it looks confusing with the parentheses. So I'm going to go ahead and rewrite it. 4 times -7. Now look, we're multiplying a positive by a negative. So I know my answer is going to be negative. What is 4 times 7? 28. So I know my answer is going to be negative 28. So if I look at these problems, I just solve them like regular, just like how I did. When you're multiplying, dividing integers, just divide or multiply like normal and then determine whether your answer is positive or negative. So for this problem, they kind of want you to see patterns. Remember, there's so many different ways to write problems. That's why I always have you guys rewrite them. So if you look at this one, this looks like a normal problem. So we have -14 divided by 7. What's 14 divided by 7? Count by 7s till you get to 14. 7, 14. You get 2. Now, is your answer going to be positive or negative? Look back over here to determine whether your answer is positive or negative. Your answer is -2. This one I would rewrite 14 divided by -7. Now again, is your answer going to be positive or negative? I'm multiplying a positive by a negative. I know my answer is going to be negative. 14 divided by 7, skip count, 7, 14, -2. Now if you look at this one, you have a negative in front of the parentheses. Remember what I said last time. If you have a negative sign in front of the parentheses, that negative sign applies to everything inside. So if you want to rewrite it, rewrite that negative in front of the 14 and also negative in front of the 7. So that problem is technically saying -14 divided by -7. All right, so if I circle this, I know that I have -14 times -7. I know if I do step 1, I ignore the signs and divide like regular. 14 divided by 7, skip count by 7, 7, 14, this is going to give me 2. And if I look at step 2, determine whether my answer is positive or negative. If I have a negative and a positive, that's going to be negative. If I have a negative and a negative, that's going to be positive. Look, you're multiplying two negative numbers. So you know your answer is going to be positive. Now the question says, are the answers to these quotients below the same or different? Why or why not? Go ahead and answer that. Are the quotients, you know a quotient is an answer to a division problem. So are all the quotients the same? Now if you looked, you should have gotten no, they're not the same. You see that A and B gave you -2 and C gave you +2. -2 and +2 are not the same. If you have -2, if you owe somebody $2 and you have $2 in your pocket, those are two big differences. So it's so important to make sure that you're careful, because if you accidentally get a negative and it's a positive, your whole answer is incorrect. Now I want you to pause the video and try to solve these, and then afterwards I will solve it with you. So remember, step 1, ignore the signs of multiply and divide like you typically do. Step 2, determine whether your answer is negative or positive. Go ahead and pause the video. So I'm going to go through like I typically do and go through the steps. 1, ignore the signs of multiply and divide like you typically do. 48 divided by 4. This is where skip counting is important, because if you don't know how to do 48 divided by 4, you can at least skip count to get to your answer. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. I know 48 divided by 4 is going to give me 12. I know both of my dividend and my divisor are both positive, so I know obviously my answer is positive. So now I look at this next problem that says negative 48 divided by negative 4. So again, you can skip count, but since I already solved it, I know my answer is 12. However, I need to see if it's positive or negative. I look at my signs to determine if it's positive or negative. I multiply two negatives. Sorry, I'm dividing two negatives, so I'm gonna get a positive number. Look at the next problem, negative 48 divided by 4. So I know 48 divided by 4 is going to give me 12. Now I just need to determine if it's positive or negative. I'm dividing a negative by a positive, so I know my answer is going to be negative. I look at the last one, 48 divided by negative 4. Again, I know it's going to be 12. However, I don't know if it's going to be positive or negative. So I need to look at step 2 to determine whether my answer is positive or negative. I see I'm dividing a negative by a positive, so my answer is going to be negative. I want you to take a moment and just look for patterns that you see. So like I said previously, we'll be working on 2 different lessons today. Now we're going to move into converting fractions to decimals and decimals to fractions. So if you look to the left, you'll see my steps on converting between fractions and decimals. You know, if you have a decimal, you're going to turn to a fraction. If you have a fraction, you're going to turn to a decimal. Here in A, I see a decimal, so I know that I'm going to use the first one, turning decimals to fractions. So it says step 1, say the decimal. So if I say the decimal, and on the next slide, I will add a place value chart because it's so important for you to understand place value, or turning decimals to fractions will be extremely hard for you. So that's the prerequisite knowledge that you need to have. So if I say this number, I know, because I know place value, before the decimal, that's my ones place. This is my tenth. I'm not going to spell the next one out. I'll just put hundredths, thousandths. I'll just put TH at the end. Thousandths. So you know that's my tenths, hundredths, thousandths, okay? When you say the number, you just say it like regular. So for example, if I had something in the ones place, let's say I had 5 in the ones place, I'll say 5. When I get to the decimal, whenever you get to the decimal, say and then you say the number and the place value that it ended off in. So if this was a 5, I would say 5 and 218 thousandths. However, there's nothing in the ones place, so you don't have to say anything. So just go ahead and say what's after the decimal point. So I see 218, and it's in the thousandths place. So that's 218 thousandths. So I did step 1. I said the decimal, 218 thousandths. Now you write the decimal how it is stated, 218 thousandths. That's how you write as a fraction. And then the last step, you just simplify. I could see that 2 can go into both of these numbers. So if I divide numerator and denominator by 2, I get 109 over 500. And that's how far it simplifies. So I know my answer is 109 over 500. So I'm going to do the steps again. Go ahead and look at step 1. You know this is a decimal. You need to turn to a fraction, so you know you'll be using these steps. So it says say the decimal. I know that this is my ones place, my tenths, my hundredths. So I know the number ends off in my hundredths place. I don't have to say the ones place because there's only 0 there. So I know that is 16 hundredths. So you just write it like how you say it. Now this is step 2. Now just find any factor that can go into both. I know 2 can go into both. 2 can go into 16, 2, 4, 6, 8, 10, 12, 14, 16, 8 times. 2 can go into 100, 50 times. Now I know I'm not done. I know 2 can go into both 8 and 50. I know 2 can go into 8 4 times. 2 can go into 50 25 times. So I know my answer is 4 over 25. However, let's say if you noticed, oh look, 4 can go into both of these numbers. 4 can go into 16 4 times. 4 can go into 100 25 times. Notice that you still got to the right answer, except you needed an extra step for this. So as long as you know any factor, you don't have to know the greatest factor, as long as you know any factor that can go into both the numerator and denominator, you can still get to your answer. That's the most important point that I want you to take away from this slide. So I want you to pause the video and try to do this by yourself. Do step 1, say the decimal. Then do step 2, write the decimal as it is stated. Then do step 3, simplify. If you're confused on place value, I need you to go back into this way and look at the place value chart. So I'm going to do step 1, say the decimal. I know that is 2, because that's 2 ones. Remember, you get to decimal, remember you say and. 2 and 72, and where does it end off in? Hundreds. So that's 2 and 72 hundredths. Now you write it like how it is stated. 2 and, write the fraction, 72 hundredths. And then you just simplify. 2 and, I know what number can go into both, 72 and 100. I know 2 can go into both. So if I divide the numerator by 2, I get 36. If I divide the denominator by 2, I get 50. So I also know that that can still simplify. I know 2 can go into both of those again. If I divide the numerator by 2, I get 18. If I divide the denominator by 2, I get 25. Now I look and see, is there any other factor that can go into both 18 and 25? And it looks like there isn't. It looks like the factors of 18, you have 1, 18, 3, 2, 9, 6. Factors of 25, I know I have 5 and 5. So there's no common factors, so I know I cannot simplify anymore. My answer is 2 and 18/25. So when you're turning a decimal into a fraction, make sure you say the place value. So, you know you have tenths, hundredths, thousands, 10,000s, 10,000ths. Sorry, I need to add the TH again. So, you know if you say it, you know you just have 5 10,000ths. Another way to say it is, well, we'll just say 5 10,000ths. And you just write it like how you said it. 5 10,000ths. And then you simplify. All right, I know 5 can obviously go into both of these numbers. How many times can 5 go into 5? One time. Now, how many times can 5 go into 10,000? And if you don't know how to do it this way, just do it long division. So you know that goes into 10,000, 2,000 times. Just think 5 divided by 10 is going to give you, 10 divided by 5 is going to give you 2, but then just add the 3 zeros. So you know that's 2,000. So I know my answer is 1 over 2,000. So now I want you to think about a few questions that are super important to what we're working on. What are decimals? What would you consider to be decimals? I'm going to give you a brief moment to answer before I explain what the answer is. So decimals specify points on the number line by repeatedly subdividing intervals into tenths. If a unit is divided into 10 equal-sized pieces, one piece will be 1/10 of that unit. Second question, take a moment to answer this. Use the meaning of decimal to relate decimal place values. So each place value in a decimal is 1/10 of the value of the place value to its left. This means that the denominators of the fractions that represent each decimal place value must be powers of 10. So take a brief moment to write your answer to this question before I give you the answer. Write the number 3/10 as a decimal. And actually, I'm going to work this one out with you. Make sure you look over here. Now you see it's a fraction, so you have to turn to a decimal. You're going to divide numerator by the denominator. Your numerator will become your dividend, and your denominator will become your divisor. So if you look at my answer, I'll simplify it in kindergarten terms. Your numerator will go inside the box, always, and your denominator will go to the outside. So your number on top will go inside, and the number on bottom will always go to the outside. The inside part is called your dividend. The outside part is called your divisor. So if I'm going to do a division problem, I put 3 on the inside, 100 on the outside. But wait, that doesn't make sense. How can I fit 100 into 3? You can't. We're going to get a fraction, okay? So here's what I'm going to do. I'm going to turn that 3 to 3.00. So then you go through the regular division steps. What are our steps to dividing? Divide, multiply, and subtract. Bring it on down and bring it on back. Divide, multiply, and subtract. Bring it on down and bring it on back. So you do divide. How many times can 100 fit into 3? It can't. Make sure you line up these decimals. If you have a decimal down here, you need to put a decimal up there. How many times can 100 fit into 30? It can't. 0 times. You're still on divide. You're not done with divide until you write a number. How many times can 100 go into 300? 3 times. Multiply. 3 times 100 gives you what? 300. Subtract gives us 0. There's nothing to bring down, so we're done. So our answer is, I don't want you to say point, ever. I want you to say the answer without saying point. Let's see if you can do it without me. Our answer is 3 hundredths. So we're going to go through these steps again. Remember, when you're turning a fraction to a decimal, your numerator is going to become your dividend, and your denominator is now going to become your divisor. Make sure you add your decimal point because you know 20 cannot fit into 3. So, you probably won't need that extra 0, but I'm going to keep it there for now. How many times can the steps to division problem are divide, multiply, and subtract. Bring it on down and bring it on back. I need you to remember long division. If you don't remember anything else, please remember how to do long division. So how many times can 20 go into 3? It can't. Make sure you have a decimal down there. You have to bring the decimal up. Because if you move the decimal one place over, you're either going to be multiplying or dividing by 10. Your whole answers could be wrong. So your decimals have to be lined up. Make sure you put a number over a number, a decimal over a decimal. Line everything up when you're doing long division. How many times can 20 go into 30? It can go into 30 one time. Now that I finally wrote a number, I'm done with divide. Now I'm going to move on to multiply. So remember, divide, multiply, and subtract. Bring it on down and bring it on back. Multiply. 20, whenever you multiply or divide, you're always going to use this number and the last number you wrote. 20 times 1 gives you 20. Subtract 10. Bring it on down. 100. Bring it on back. Divide. If you don't know how to do 20 divided by 100, do 2 divided by 10. That's going to give you 5. Multiply. 5 times 20. 100. Subtract. 0. Bring it on down. Bring it on back. Divide. 0. Multiply. 0. So really, you can stop right here. So this will be your answer. Let's go ahead and say it out loud. 15 hundredths. Good. Let's do the next problem. So we have, write the fraction as a decimal. Remember, numerator will become your dividend. Denominator will become your divisor. Go ahead and divide. All right, so 25 into 1, it cannot go into 1. 25 into 10, 25 can't go into 10. Remember the steps, divide, multiply, and subtract. Bring that down. We're still on divide right now. You're not done with divide until you write a number. 25 into 100. Oh, think about quarters. 25 can go into 100. 25, 50, 75, 100. 4 times. Multiply gives you 100. So if you multiply 4 times 25 gives you 100. Subtract 0. Nothing to bring down, so you're done. So you know this is your answer. 0 and 4 tenths, or you could just say 4 tenths. So I want you to try to solve these without me, and then you can listen to me to explain afterwards. Let's see if you can do this one by yourself, and then just use me to check your answer. So go ahead and write on your paper and solve this one without me. Go ahead and pause the video. So if you can turn a fraction to a decimal, remember your numerator goes inside, that becomes your dividend. Your denominator is going to become your divisor. All right, so divide. How many times can 40 go into 8? It can't. We're still on divide. How many times can 40 go into 80? It can go into 82 times. Multiply. 80. Subtract. 0. Nothing to bring down. You're done. All right, so our answer is 0.2, but you remember I don't like when you say 2, so say it without saying point. Say the number and what place value it's in. The answer is 2/10. So we're going to convert this fraction to a decimal, 3/16. So remember that whenever you're turning a fraction to a decimal, your numerator goes inside, your denominator becomes your divisor. All right, so how many times can 16 go into 3? It can't. How many times can 16 go into 30? It can go into 30 one time, because 2 times 16 gives you 32. You'll go over. Multiply 16, subtract. You need to regroup. Bring it on down. And bring it on back. Divide. How many times can 16 go into 140? It can go into 8 times without going over. Multiply 16 times 8, you'll get 128. I'm doing this in my head, but you may need to work it out on a separate sheet of paper so you don't get confused. And you subtract 140 minus 128 gives you 12. And bring it on down, bring it on back. We're just going to keep going. Divide. How many times can 16 go into 120? I know it can go into it 7 times without going over. Multiply 7 times 16 gives me 112. Ooh. I'm going to continue over here. Gives me 112. So now I have 120 minus 112 gives me 8. And then I'm going to bring the next number down. And then bring it on back. Divide. How many times can 16 go into 80? 5. Multiply, it's going to give me 80, subtract 0. So I know my answer is 0.1875. However, I want you to say it without the decimal. Remember place value, this is tenths, hundredths, thousandths, 10,000ths. So I know the problem says to convert each fraction as a decimal using equivalent fraction. However, I'm not a big fan of that strategy, so I'm going to solve it the way that we've been solving it. So again, make sure you put your numerator on the inside, that becomes your dividend, denominator outside, that becomes your divisor. Then just do long division. Keep going until you pretty much can't go anymore. If you realize you're going on for a long time, then I would stop. However, keep going until when you subtract, you get 0. All right, so 5 divided by 7. 5 can go in 7 one time. Multiply 5, subtract 2. Make sure you see a decimal down here, so please line up your decimals and your numbers. That means I need to see a number over the 0, a number over this 0, a number over this 0. All right, so where were we? Subtract, okay. Bring it on down, bring it on back. Divide, that's going to give me 4. Multiply 20. Subtract, keep losing that decimal. Subtract 0, bring it on down, bring it on back. Divide, you know you're going to keep getting 0 from now on. So I'm just going to stop right here. I know my answer is, you don't say 1.4. Figure out the other way to say that decimal without saying 1.4. So what you should have said was 1 and 4 tenths. So we're looking at this next problem. So we have 11 divided by 32, because you know the fraction sign also means division. So 11 goes on the inside, 32, your denominator goes on the outside as your divisor. You just keep going until you can't go anymore. Okay, so remember the steps along division are divide, multiply, and subtract. Bring it on down and bring it on back. So divide. How many times can 32 go into 1? It can't. How many times can it go into 11? It can't. Line up your decimals. How many times can 32 go into 110? So now you see, if you struggle with this, to the side, just do 32 times 1, 32 times 2, 32 times 3. Do that to the side. If you can't do this in your head, do it to the side, please, so you don't get the wrong answer. So I know 32 can go into 110 3 times without going over. So if I do multiply 3 times 32, gives me 96. Now I subtract. So now I do 110 minus 96 equals 14. Then I bring it on down, bring it on back, divide. How many times can 32 go into 140 without going over? It can go into it 4 times. Put that 4 right above the 0. Make sure you line your numbers up, please. So I'm going to multiply 4 times 32. This will give me 128. So now I have 140 minus 128. So subtract and bring down, bring it on back. Divide. I'm going to continue it over here because I'm running out of space. So I'm going to continue it from here. So divide. How many times can 32 go into 120, but you cannot go over? 3 times without going over. Multiply. And you already did 3 times 32 already. What is 3 times 32? 96. Subtract. 120 minus 96 gives you 24. By the end of this lesson, you should be really good with long division. Then you bring it on down. Remember, we don't have space, so we're just going to bring it down over here. And then you bring it on back. Divide. How many times can 32 go into 240 without going over? If you have to do it to the side, remember, do it to the side. 7. Multiply. What is 7 times 32? Gives you 224. Subtract. 240 minus 224 gives you 16. Then you bring it on down, bring it on back. Divide. How many times can 32 go into 160? It can go into it 5 times perfectly. Multiply gives me 160. Subtract, I get 0. Now you are done. So you know your answer, and you can go ahead and work on saying it, writing your place values, and then saying it. So this is the last problem of the day. Now we have 35 over 50. We're going to turn that into a decimal. So you just know that you're going to divide numerator divided by denominator. So you know 35, number on top would always go inside, number on bottom will always go on the outside. And you just keep going until you can't go anymore, until you subtract and get 0. So 50 can go into 3. It can't. How many times can 50 go into 350? It can't. Make sure you line up your decimals. How many times can 50 go into 350? So think 50, 100, 150, 200, 250, 300, 350. You know goes in to that number 7 times. Another way to do it is say 35 divided by 5 gives you 7. Keep losing my decimal. All right, multiply gives you 350. Subtract 0. So you know your answer is, and you can go ahead and work on saying that. All right, so you should have gotten 7/10.